You know how your music app just knows you'll love that next song? Or how a shopping site shows you a bunch of shirts that are just totally you? It really feels like magic, right? Well, today we're going to pull back the curtain on how AI finds similar things. And the secret? Well, you're not going to believe this. It's hiding in a 2,000-year-old math book.
Okay, let's start with something you've definitely done. How on earth does your phone find every single picture of your dog, even when you haven't tagged any of them? I mean, it finds the puppy pictures, those blurry action shots, the one where he's sleeping. How does it know they're all the same furry friend? It's kind of wild when you think about it.
Yeah, it really does feel like a modern magic trick. But, like any good trick, there's always a clever method behind the scenes. And that's exactly what we're going to break down right now.
So, the secret engine behind all this AI magic, it's not some brand new, super complicated code that some genius cooked up last year. Nope, the secret is actually really, really old math. We're talking about a concept that I kind of like to call the 2,000-year-old ruler. So its official name is Euclidean distance. Yeah, named after that Euclid, the ancient Greek mathematician. You might even know it by another name, Pythagorean distance. And all it is, really, is just the length of a straight line between 2 points, the most direct path, as the crow flies. And this idea has been around forever. Seriously, it's been built on for centuries. It all starts way back in ancient Greece with Euclid and Pythagoras just laying down the rules of geometry. Then, fast forward more than 1,000 years to 1637, and a guy named René Descartes gives us coordinates, the x and y axes from math class. Then, in 1731, another guy, Alexis Clairaut, publishes the actual formula we use. And by the 1800s, mathematicians figured out how to use this whole idea in, more than 3 dimensions. So what we're talking about here is a rock-solid, totally time-tested concept. And really, at its heart, it's just the good old Pythagorean theorem you learned back in school. Remember? A squared plus b squared equals c squared? You take the 2 short sides of a right triangle, and they help you find the length of the longest side, the hypotenuse. That's it. I'm not kidding. That's the ancient ruler we're using.
Okay, so we've got a ruler for measuring actual physical space. Great. But how does that help a computer figure out if 2 pictures are similar? This is where things get really cool. We have to take a giant conceptual leap. So instead of measuring the distance between physical places, like from your house to your school, we're going to start measuring the distance between ideas. Just think about it, calculating the vibe distance between a heavy rock song and a super bubbly pop song. We're literally taking a physical ruler and using it in this totally abstract world of concepts. So how does that even work? Well, the AI has this amazing trick. It turns everything into a long list of numbers. And this list has a name. It's called a vector. You can just think of it like a unique digital fingerprint for anything. So an image, it gets turned into a bunch of numbers for its colors, its shapes, its textures. A song, that becomes numbers for tempo, key, and energy. And that list of numbers, that becomes its unique address, its coordinates on this gigantic map we call idea space. And here's the key. Once everything has its own numerical address, the rule is super simple. The smaller the distance between 2 of those vectors, the more similar the 2 items are. So a picture of a golden retriever is going to have coordinates that are super, super close to another picture of a golden retriever, but its coordinates will be miles away from a picture of a sailboat. Simple as that. Okay, so where does the AI store all of these coordinates? It uses something we can think of as a kind of AI superlibrary. This special library has a technical name. It's called a vector database. Now, unlike a regular library that organizes books by, say, the author's last name, a vector database organizes everything, images, songs, text, by its meaning, by how similar things are conceptually. It's like a library where all the books about adventure are put right next to each other on the shelf. And it doesn't matter who wrote them or what their title is. It's all about the vibe. So let's go back to your dog pictures. When you search, here's exactly what's happening behind the scenes. First, your phone takes the picture you gave it and turns it into its special list of numbers, its vector. Second, it plots that vector on that giant map of idea space. Third, it uses our 2,000-year-old friend, Euclidean distance, to find all the other vectors that are its closest neighbors. And finally, it just shows you those neighbors. And boom, there's every picture of your dog.
All right, here's a little pro tip for you, a little peek behind the curtain of computer science. See, to do this millions, even billions of times a second, computers need a shortcut. calculating that distance involves a square root, which is kind of slow for a computer. So here's the hack. They often just compare the squared distances instead. Think about it. Squaring numbers doesn't change which one is bigger or smaller, right? So it gives the exact same who's closest result, but it is way, way faster to calculate.
So let's bring this all back to you. This isn't just some abstract theory we're talking about. This 2,000-year-old ruler is actively measuring and organizing your digital world every single day.
I mean, it's the engine behind visual search when you click Find More Images like this. It's the reason your music and movie recommendations are so spookily accurate. It's just finding songs with a similar vector. It's used to detect plagiarism by measuring the meaning distance between two essays. And it's totally fundamental to how chatbots actually understand what you're asking, so they can give you a decent answer. So think about where we started. We started with a simple ruler to measure the distance between two dots. And now, we're using that exact same idea to map the entire universe of human thought. Which leaves us with a really fascinating final question. Now that we can actually measure the distance between any two ideas, what's the next big question we can ask? What new connections are just out there waiting to be discovered?